Morning, this is Nandeep. Today is last and final session for balanced cantilever bridge analysis, and today the emphasis would be on construction stage, moving load generation and results. Now since this is a mass webinar, the attendee mic have been muted to avoid any disturbance. If you can hear my voice, please raise your hand by clicking the button shown by number 2. Okay, so I have enough raised hand. I'll be proceeding. So if you have any questions, please type those in the box shown by number 3. At the end of the session, I'll be answering as many questions as I could depending on the time. And at the end of the series, most probably by Tuesday or Wednesday evening, you will be receiving a document with answer to all the questions. So these were the topics covered on day 1. The material properties, section properties were defined, the superstructure was done, tendon profile was defined, and pre-stressing load was given to the tendons. After that, yesterday we did the manual modeling for the substructure. We gave the bearings, we made several links, we gave all the loads that were to be given on the structure, and we defined the time-dependent material property that would be used for the construction stages. And today what we'll be covering is the construction stages, moving load generation, the load combinations, the results, and beam detail analysis along with the dynamic report. Okay, so yesterday I showed this slide. This covers basic manual way of defining the construction stages. Okay, you have to define materials, assign elements to groups, define the time-dependent material properties, enter the construction stage data. You have to give which groups are to be activated, deactivated, and all. Define the tendon profile properties, assign those to the groups and stages, perform the analysis, and check the results as needed. So now I'll be showing this in the model. Okay, so first of all, how to make a construction stage. So as you can see over here, already the wizard had made the construction stages for each and every stitch segment or each and every segment that is made. So if you just want to view the stages that have already been made graphically, then you can view it like this. Over here, this is the base stage wherein each and every node and everything that you have made would be shown. If you want to see the first construction stage, then this is the first construction stage. This is the second construction stage wherein you can notice that one segment has been added. Third, fourth, then say this is the 10th construction stage wherein the construction on both the integral piers is done and the middle stitch segment is remaining. So when we move to the next construction stage, as you can see, the stitch segment has come into picture now, and so now the FSM, the supported part of the bridge, that has also come into picture. So this is how construction stages are made. Now looking at how to enter the data for construction stage. So yes, this data could be entered or edited only in the base stage. So you'll have to go to base stage first of all. Okay. Now this small button over here, that could be used to directly go to construction stage box. With besides that, you could also go to loads, construction stage, and define construction stage. So this box pops up. Now if you want to add a new construction stage, all you have to do is you have to click on this add button. Okay, give some name, say stage 14. And I'll be adding this stage to, check the final time dependent effect after say a span of more than 100 years. So I'll be entering the duration as say 40,000 days. Okay. And okay. So as you can see, stage 14 of 40,000 days has been added as the last stage. Okay. Now, yesterday we talked about defining groups, that only groups could be activated or deactivated in a construction stage. So, if we see the first construction stage, right, then these are the elements that we are seeing in the first construction stage. Okay. If we go to groups, then these elements have been assigned to certain groups. To check those groups, there are one structure group, there is boundary group, and there are load group. Nothing has been assigned to tendon group because as we discussed yesterday, everyone, can you hear me? Okay, I think there should be no issue. So as we had discussed yesterday, the structure, boundary and load groups need to be assigned, and only those could be activated or deactivated in construction stage. Tendon groups are only defined to check the result of certain tendon grouped together. So now these are the groups that are activated in CS1. So if we go to CS1 and we check, so what they have activated in, there are three, as I said, structure group, those are shown in the element. Then boundary groups that are shown in the boundary, and the load group that are shown in the loads. So these are all the groups that are available. Okay. And the groups that have been activated in this particular stage, that is stage 1, are the peer table 1, peer FP2, peer table 2, and so on. These are the several groups that are activated in stage 1 itself. Okay. Again, the pile springs that we defined yesterday, since we are enabling the piles in the first construction stage, obviously the pile springs will also have to be enabled. So those are activated in stage 1, and these are the loads: self-weight, then formwork, traveler, wet concrete, as well as pre-stressing. These are the loads activated. Okay. Now, how to create these groups? So say we just have to right click on this and new. When we click on this dialog box opens up. So define structure group. Okay, so over here, if you name something, say group 1, and you say add. Okay, it has to be done in base stage only, again, as I mentioned before. So we go to base stage, and we want to create a new group. So new, and we say group 1, add. Okay, so now this group 1 has come into picture. Besides that, say you want to create 10 groups from ranging from group 1 to group 10. So in that case, you can do it directly. So I've removed that group 1. Instead, I'll write group over here, and I'll say suffix 1 to 10. If I say add, then as you can see, automatically 10 groups are created. Okay, so this is how you can create a structure group. Now, say these groups that we created, they have come over here. Okay. Now say to the first group, I want to add this much part, the first substructure. Say just for the sake of showing how to add elements to group, then what you have to do is, you have to simply select those elements. Okay, once that is done, say you want to add these elements to group 1. So you have to click group 1, you have to drag and drop it in this window. So once you do this, See, if you double click on group 1, as you can see, all these elements have been assigned to group 1. So in this way, the elements are assigned to the structure group, which can later be activated or deactivated in the construction stage. This is a bit different for load group. Again, to create the group, it is simple. You have to just right click on load group, new, and similarly you can add new group. This is the defined load group. Okay. However, if you want to assign any load to the load group, now since the loads have already been created, you will have to change the load group. Okay. I am showing it in this way because we could not define the load group and everything in the first day itself, because you are not aware of what construction stage is at that time. So we had assigned loads to the default group. So now we will have to change the load groups. That has already been done over here. But to do that manually, what you have to do is you have to right click, go to load tables. Okay. So here they will show what all kind of loads could be applied. Say for now I am taking the tendon pre-stress loads, okay, because we have applied several tendons. So as you can see over here, the load groups that we have created, those are available. Okay, so by default they would all be assigned to the default group, but now you could assign that to any of the group that you have created, and in this case it is PS19 group. So these tendons would be activated in when this group is activated in the construction stage. Okay. And similarly, it is for boundary group. The pile springs that are created, if you want to assign that to a group, what you have to do is you have to first of all create the boundary group by clicking on new as shown before. You have to select the nodes, okay, for which you want to assign that group. Okay, and you just have to drag and drop it. If you will drag and drop it, it will show what all kind of boundary conditions you would like to assign to this group. Like one node could have a spring support, a fixed support, an elastic link. It can have many things. So if you want to assign only particular kind of condition to the group, you can do that as well. If you want to assign everything, then that can also be done. You just have to click on OK and everything would be assigned to that group. So this is how the groups are created, and these could be activated or deactivated in a construction stage. Okay. So for CS1, say, if here it is given that peer table 1 is activated at the age of 7 days. So you have to give the age over here. So when your element is say made, or when it is coming in the model, it is already 7 days old. Say you have a girder, okay, that is cast somewhere in the casting yard, and you are moving it at your bridge location when the age of the girder is 14 days. So you could enter that age over here, 14. You can click on that group and you can say add. Okay, I have selected segment 1-4 here just for the sake of showing it. And if I say add, then segment 1-4 is added at the age of 14 days. Okay. Similarly, say there was some temporary element that was activated and which you want to deactivate. Then that could be done by adding that to this box. Okay, you just have to select the element from the element group and you just have to click add over here. It's as simple as that. Similarly, it could be done for boundaries. They could be added in their original position over here, or they could be added in their deformed position. Deformed position means it will consider some deformation due to the element, since the aging of element happens, there will be some deformation, and that is considered, and the boundary would be added to that deformed position. That is the deformed condition of the boundary. Okay. And the load. So self weight is activated from the first day itself. If you want to add some additional step in between, say let us say about wearing coat and say crash barrier. So say your crash barrier is activated on day 1 and your wearing course is going to be activated 5 days after that. So in that case you could add an additional step over here. Say I say 5. Okay. And if I say add, Okay, then as you can notice, this 2 number 5 is added over here. And say I'm just selecting a random load, then here the option will be shown when I want to activate it. Whether I want to activate it on first day, last day, third day, the step that was already there, or the fifth day, the new step that we added. So say I say 5 and add, then FT91 is added on the fifth day. And say similarly, if certain thing has been activated in some other group, certain load has been activated in some other construction stage previously. If you want to deactivate it, just have to click on that and add it to the deactivation box. So that would be deactivated. Say for example, when you are going for a composite construction, in that case, the dead load for the slab that is just being poured, the wet concrete won't be able to take any load on itself, right? It won't be having any stiffness or anything. So that load has to be added as UDL on the girders. However, 21 days later, when formwork and everything is removed and it starts acting as a composite section, at that time you'll have to deactivate that load. Why? Because since that is cast, the load would be added in this self weight itself. So you don't need to add it as a UDL again. So that UDL will have to be removed because that element is now activated. So those kind of things could be done in load deactivation box. Okay. So this was about the construction stage. Now we'll be having a look at the moving loads. So I'll go to presentation again. Okay. So first we need to decide where we have to place the lanes over the deck. So crash barrier and footpath together are considered to have 1 meter width at both the ends. So total carriageway width in this case is 8.13 meter. Now according to IRC 6, if the width is 8.13 meter, then it will have 2 lanes of class A and 1 lane of class 70R. So in all we need to define 3 lanes, right? Because the lane that would be considered for class A would be different from the lane that would be considered for class 70R. So these are the lanes that we need to consider. Class A1, which would be at 2.765 meter, or rather 2.55 meter from the edge. So this distance 2.765, this is the eccentricity that would be given. Now how this is given, I will show you in the model. So first of all we'll go to the load tab, the moving load, we'll select India as the moving load code. Okay. Now first of all we'll have to define the traffic lanes. So I'll be going back to the line model. Okay. Now there are 2 options, traffic line lane and traffic surface lane. If you are defining the element on which the moving load is to be applied, if it is a plate element, then you have to select traffic surface lane. However, if it is a line element, then you have to select traffic line lanes. So in this case, since our box girder is modeled as a line element, we'll have to select the traffic line lane option. Okay. I'll click on add. I'll give the name as say class A1. Okay. Now this is the eccentricity. The eccentricity is always to be given with respect to the distance from the reference element. So in this case, our reference element would be obviously be the line element for the box girder. Now in the presentation, what we saw is what will be the distance of the center for class A vehicle from the edge of the deck. So that has to be calculated by 10.13 by 2, that is half, minus the footpath width, minus minimum clearance for class A, that is 0.15, minus the half of wheel width, which is 0.5 for class A vehicle, and minus half of 1.8 meter, which is the width of class A vehicle. So when you do this, the eccentricity turns out to be 2.765 meter. Okay, so we'll enter this 2.765 in the eccentricity box. So wheel spacing is 1.8 meter. We'll say this has an impact factor of 0.2. Okay. Okay, I'll show you a slide on this lane element and cross beam distribution as well. First of all, I enter this eccentricity 2.765 meter. Now, so if you are making, say, a grillage model instead of a line model, single line model, then you have to select the option of cross beam distribution. Okay, in lane element, what happens is the vehicle load, the moving load would be assigned as vertical load as well as the bending moment, that is the moment based on the eccentricity. Say vertical load is of 100 ton is placed at an eccentricity of 2 meter, then for the line element what will happen is 100 ton will directly be applied at that point, and a moment of 100 into 2, that is 200 ton meter, would also be applied at the same point. So this is how this distribution will happen if a lane element option is selected. However, if the cross beam element option is selected, then in that case, as shown in figure, though your reference element would be, say, main girder 3, okay, you have given certain eccentricity, and say that places the 100 kilonewton load as shown by the arrow over here in the figure, then in that case that 100 kilonewton load would be distributed to the cross beams, and from the cross beams that load will go to the main girders or the nodes which are supporting that cross beam. This is how the distribution will happen for the grillage element. So whenever a grillage model is used, you have to select the cross beam option, and if it is a line model, you have to select the lane element option. Okay, so since in our case it's a line model, we'll be selecting the lane element option. Okay, so lane element direction will consider both. So the vehicle would be going from in one direction as well as it would be returning in the opposite direction, considering it as a 2-lane road. Okay. Now there are 3 ways in which you can select the vehicle motion path. If it's a straight element, then going by 2 points, just clicking over here and will do. But since this is curved, what will happen is the vehicle will travel along straight path, so that is not feasible for us. Using the picking method, you will have to select individual element numbers on which your vehicle would be placed. Again, that would be a cumbersome process. So what we will do is we will do it by number. So now our vehicle would be running on the deck elements only, obviously, right? So we'll have to select all the deck elements. Say we use the select by window option. We select all the elements. Okay. Now this window over here, it shows the elements which have been selected, and this window shows the nodes that have been selected. What we are interested in is the elements that have been selected. So we'll just copy the element numbers and we'll input that over here. Okay, so 1 to 55 has come over here. I have given the eccentricity, the wheel spacing, the impact factor, the vehicle direction, and what elements. Okay, I just have to click on add. Okay, so as you can notice over here, the lane for the class A vehicle has been created. Okay, say view in plan. I'll just unselect these. So this is the class A vehicle 1 lane that has been defined. Okay. Similarly, a lane for class A, 2nd lane would be defined, and a lane for class 70R would be defined. Okay. So the second lane would be at an eccentricity of minus 0.735 meter. That is, initially the vehicle was running on the right side of the center. Now it would be running on the left side. So that's why the sign has changed from positive to negative. And similarly, the distance had been calculated for class 70R. And since this is two lane, the cases that would be considered over here are class A in first lane, class A in second lane, class A in both first and second lane, and class 70R in the lane that was defined for class 70R. Okay, so now we'll be moving to that. So I have defined the lane for class A vehicle, right? But no vehicle has been defined yet. So I'll go to vehicles. I'll say add standard. Okay. So this class A is there. Besides that, class 70R, class B, class A, and others are there. So we'll say class A, apply, and say class 70R also will add. Okay. Okay. So class A and class 70R have been added. Besides that, if you want to define your own vehicle, you can do that by using the add user defined box, wheeled vehicle, tracked vehicle, or whatever kind the case might be. Okay. Now the vehicles have been defined, the traffic lane has been defined. Okay. We have to create the moving load case for that. So say if I want to add class A vehicle to the lane that has been defined, we click on the moving load case. We click on add. We'll give it a name, say class A lane 1. Okay. Now there is an option for auto live load combination, but it will be better if I show you manually how it's done. I will to click on add. Okay, since I have defined only one lane, there is only one lane shown over here. So I have to select the vehicle, say class A, and add. Say okay. And okay. Okay. So this moving load case has also been defined. That will also show over here that yes, moving load case 1 has been defined. Okay, so in this way, other vehicles, other lane, and other moving load cases are defined. So all of this have been done in final model that was made for today. Okay, so the traffic lanes that are defined are, as I said, this was done in the previous model. This is first lane. This is the second lane. The class 70R, 70R, class A1 and class A2. Okay, these are the two vehicles that are defined, and these are the load cases. Class A in lane 1, class A in lane 2, class A in both the lanes, and class 70R. Okay, now I have already performed the analysis on this model, as otherwise the analysis performance will take longer time. Besides that, there are options available for controlling how you will be doing the moving load analysis, or what loads you will say consider, or what are the conditions for the construction stage analysis. So to manually modify those, what you have to do is you have to go to analysis, and these are the analysis control options. So first on I will show for the moving load. Okay, say by default what will happen is the influence line generation points. Over here it is shown that numbers per line element is 3. So if you want to go for more details, what you can do is you can increase the number. You can also specify the distance between the points. Say you want the vehicle to be placed at 0.5 meter distance. So increment you want to be 0.5 meters. So you could enter that 0.5 over here, and that would be the increment. Okay. Similarly, there are options for if you want normal force, or if you want concurrent forces acting together. Besides that, options are also there if you want to perform analysis for certain group only. Say you are performing the moving load analysis, and you want the pile reactions only. So in that case, what you will do is you will create a group. Say for I want it for force and moment. Okay, rather reactions. I want for reactions, and I have created a group. Okay, so over here, if I will select say any one group, structure group, say support node. Okay, and if I'll perform the analysis, then I'll be getting the result at these locations only. The advantage in this would be the analysis time would be considerably reduced, and you can obtain the results that you want quickly. Generally, it is sufficient to go with the options as given in default, but if your model is very big and you know the specific elements for which you want the result, then you could use the calculation filters. And again, the maximum successive vehicles. Over here it is 1, right? Now, if your bridge is long and if the number of vehicles that would be, coming onto the bridge, it is more. Say the length of the vehicle plus the length of the clear spacing between the two vehicles. If the length of the bridge is more than that, and if you want to increase the maximum number of successive vehicles, you can do that over here. I think the maximum allowable is 10. So until 10 vehicles could be added to the model. Okay. And now for the construction stage analysis. Over here, that analysis control is also given. Say if you have made the change in elements such that it could be reflected after the, say, 5th construction stage only. So you have to click on restart construction stage, select the one for which you want to do it. Okay. And say you want to run the analysis only until, say, 4th stage, then you have, instead of last stage, you have to select other stage and CS4. In that case, what will happen is your analysis will start and it will be performed only until the 4th stage. So if you want to check the initial condition, what is happening, that could be quickly done over here. Besides that, there are options for including time dependent effect. So wherein you'll say you want to consider which kind of losses, just the creep, shrinkage, or both. What should be the iteration to be done? What is the time gap to be considered? Everything that could be specified over here. Now besides that, there are what happens is, if a certain static load is activated during the construction stage, that will always be clubbed into one load, that is construction stage dead load. This is a new load case that would be created, in which all the static loads that have been activated during the construction stage would be added. However, if you want to check the result for certain dead load case exclusively, which should not be clubbed with that particular load case, then that could be added over here. Over here, the forward traveler and the SIDL load has been added to the load cases to be distinguished from the dead load for construction stage output. This would be visible in the construction stage only. Okay. And besides that, there are several other options over here. Now for this particular model, the analysis has already been performed. So say let us shift to the initial view. At the later stage, I'll also be showing you about the dynamic report generation. Okay, so let us say we'll just add an image for that right now. Let's say right click, dynamic image report. Rather, I'll be a specific area. So I'm taking this much area. Dynamic image report. Okay, say image 1. Yeah, okay. Okay, so this image has been saved for later. Now we'll focus on the results as of now. Okay, so to view the results, you could go to results. If you want to view the bending moment diagram due to self weight, then let us go to forces, beam diagrams, self weight, MY. So I'll be selecting the legend because the values will make it too cluttered to view. And I say apply. So these are the bending moments that would be acting for this structure in the Y, that is local Y direction. Similarly, say if you want to check it for temperature gain. So this would be the bending moment acting for that. You could check the results in each and every construction stage as well. Okay. So these are the load case, construction stage dead load case that I mentioned before. That is this CS dead load. Whatever loads are activated during the construction stage, those are clubbed in CS dead load, and those are shown, the results for that are shown together. Okay. Besides that, the forces due to pre-stressing, those are shown in tendon primary, secondary. The creep and shrinkage are shown in creep and shrinkage respectively. So the summation of all these is the CS summation case. So if you'll view, this is stage 1. Okay. For stage 2, automatically, then if you switch to stage 3, again, so the bending moment and everything will automatically get updated. You can check the results at each and every stage, where it's failing, what's happening, everything could be checked from this. This is the graphical view. Besides that, if you want to check it from tables, you could go to result table and check beam forces, say. Okay, so you have to select all the elements for which you want to view the force. By default, all the elements would be selected. So if you want to view the results for some particular element only, you could select that as well. So let us say we want to view the results for, say, element number 58, that is this pier. Okay. So if you want to view the results for element number 58 only, we'll go to results, beams, forces. Okay. Number 58. Say we want to view the results for CS dead load. At the construction stage, you have to select in what construction stage you want to see. Okay, so we have selected over here the 7th construction stage. Okay, let us say all the cases. And I say okay. So it will show me the results. What is the axial force? The shear and all of it obviously not be there. What is the bending moment in longitudinal and transverse directions? Okay. It will show the load case, the stage, the step, which part, I end and J end, that is at the top or at the bottom, say. And these are the other factors, the forces and moments that are shown for the particular element. So I have selected only for one element and one construction stage, because as you can see, just for one construction stage, single element, these many results are generated. So if I had selected view all, it might have taken a bit of time, say 1 or 2 minutes, for it to generate the entire result table. Now, if you want to find out what is the maximum value over here, then you can easily copy this into Excel and you can use the max command over there to find out the maximum value. That is, if you want to do it in a tabular format. Besides that, in view, you can obviously find the maximum value. It's happening for node number 38 and this is the maximum value. Okay. So this way it could be easily done in the graphical view, but usually the reports have to be submitted, the tables have to be submitted, so that could be done from over here. It could simply be copied and a new Excel file is say created. And it could be pasted. So entire thing is there over here for you to edit if you want. Besides that, you could also directly export it to Excel. Okay. So this is a bit more on the options for the moving load analysis control. As I mentioned, the number per line lane. What is normal plus concurrent option? Yes, I forgot. So if the concurrent force for maximum moving value is required during the moving load, then you have to select the normal plus concurrent force option. Okay. Moving back to the model. Okay, so these are the beam forces that you could view. Besides that, say I'll remove these results. Besides that, say you want to know that for element number 29 over here, what is the maximum bending moment that is happening due to class 70R vehicle and what is the position of the vehicle at that time. So to know that, you can use the moving load tracer option and you wanted to know the bending moment, so you could use beam forces. Say key element is number 29. Okay, and you say apply. So this is for class A vehicle. If you want to say for class 70R, then MB max for class 70R and apply. Okay, so this is the position for that vehicle. These are the loads that are acting. Say change it to ton. Okay, so these are the loads that are acting for class 70R, and if the vehicle position is this, then maximum bending moment for element number 29 occurs. Okay. Now about the dynamic report that could be generated using this. So say we had created that one image, right? Say I'm even adding this image. So I will click right click, dynamic report image, image 2. Say okay. Okay. Now dynamic report generator is basically a tool which generates a Microsoft Word report which could be edited by the user. Not only that, it is automatically linked. Now how that will happen, I'll show you. Say we go to dynamic report generator, we create a new document. Okay, so see, this Microsoft Word document has opened up within the MIDAS cell itself. Say we are adding over here the end support peer view for balanced cantilever bridge. Okay, we are entering this much, and if you want to add the image that I snapped for the first time, the image 1, you just have to go to report 1, and there is this image 1, right? You just have to drag and drop it in this window again. So now as you can see, the image 1 has been added. Similarly, if you want to add image 2, see, that could also be done. Now since this is a model in which the analysis has been performed and everything has been done, it will take a bit longer to update the report and everything. So what I'll do is I'll show one of the most important features for this in the previous model. So I'll close this report. Okay, and I'll go to the previous model. Say in this model, I'm sorry. Say for this model, I want to replace the end support and pier with the round pier that I have provided. Okay, as well as this one. Say I want to replace these with the round pier. So before that, I'll just make a simple image without that. Dynamic report image. Okay. Okay, so this is the image that I have made. Now after the report is generated, we'll make that report. Okay, and we'll add the new image to that report. Okay, so say after the report is generated, what happens is you want to change what is happening. You want to change the pier from this rectangular to the 5 meter round pier. So you change that first of all. Say you go to section and 5 meter pier. Okay, so now the pier has been changed, and this image in report is totally useless because it is not what is being designed or submitted to the client now. So you won't have to make the entire report again. What you have to do is you have to go to auto regeneration. See, select all and regenerate. So now if you will see in this, the image has automatically been updated with the round pair that we have replaced in the model. So in this way, say after you have done a lot of analysis and everything, and you are making a few changes to the model, or say you are adding more load cases or anything, and if you have made images and the report is ready, you don't need to recreate the entire report. Just simply after you are done with that, you have to come to this, go to dynamic report auto regeneration, click it, say okay, go have a cup of coffee, and by the time you are back, the entire report would be done by itself. Okay. So now moving back to the presentation, the load combinations. Okay. Yeah. So to view the load combinations, say we'll go to the final model again. Okay. Now these are for individual load cases. What if I want to make the combinations based on IRC code? So for that you just have to go to results and this load combination. Okay. Now since this is a concrete bridge, you go to concrete design. You could manually create a load combination over here if you want. Say com1, and you can select the load cases. I want to add self weight factor to be 1.5. Say I want to add temperature gain. Say I want to add tendon forces. Say I want to add creep. You would manually do all this if you want. Besides that, if you don't want to do it manually, you can do it using the auto generation option that is given over here. Once you click on the auto generation, this kind of table will pop up. So first of all, just select the code for which you want to follow. So say IRC 6. Okay. Now here there are options. The load cases that would be considered for the auto generation, you want to consider static only, or the loads that you have added in construction stage only, or both static and construction stage. So for now, let us say we are going with the static only. We'll consider the service condition and say okay. Okay. So automatically the load combinations are generated. 104 load combinations are generated. Okay. Now we say close. For this load combination generation, you don't need to perform the analysis again, because analysis would be performed for single loads that would be acting, and load combination is just superimposition of those loads and results. So you have made the combinations now, and if you want to view the results for that, similarly just as before, you could go to forces diagram, beam diagrams, and over here that combination list is available to you. Say you want to check the maximum due to combination 101 bending moment. Just remove this and say apply. So this is the bending moment for that particular combination. Similarly, you could even check the deformed shapes. Okay. Now over here it looks like, oh my god, the bridge is definitely going to fail, but that is not the case. The deformations that are shown in MIDAS, they are very exaggerated. If you want to see the actual deformed shape, you could click on this and you would say real deform. Say real displacement as well, and okay. The bridge will look as good as straight. So to show how the structure is behaving in a very enlarged scale, the initial view that is given without all these options is like this. Okay, so you could check the deformed shapes for whatever cases you want. Over here, if you see, the deformation seems very high. So if I go to mm, and if I check the value at that location, it is barely 32 mm, that is 3 centimeters. Okay, so 3 centimeters for a big span of about 70 meters or so, it won't be visible, you won't be able to confirm it visibly. So that's why these exaggerated views are shown. Okay. Now moving back to the presentations. The beam detail analysis. Say you want to check for a particular beam element only, not at just I and J or the 4 or 5 points that are provided in between by the software directly, but you want to check it in detail, what's happening. Then in that case, you could use the beam detail analysis report. Okay. So we'll go back to the model. Just a second. Okay. So we go to, we are already in results. We'll again go to the initial view. We go to results, beam element, and over here the beam detail analysis. So once you do that, this window pops up. So we were checking for element number 29 before, right? So we'll go to element number 29. Say we are selecting some abrupt any arbitrary load combination. So load combination 66, and we say apply. Acha. So in moving load, the beam detail analysis is not performed. So we'll have to select some combination or the load case for which the beam detail analysis is done. So say we'll consider the self weight, simply speaking, for now. Okay. And apply. So now this beam detail analysis report would be made. It will take a bit of time. By then, if you have any questions so far, you could just start typing it in the question answer box, because we are almost at the end of our session. Okay, yeah, so this is the report that is generated. The image is graphically. Now over here, see, this option is given, right? This displacement absolute, what is the value at I end, at J end, what is the maximum displacement, similarly minimum, and this is for user defined. Okay, so if you want to change the location, say this is the default location where it is showing. If you want to change it to this location, say, so you just have to click over there, and if you notice, the value X has changed, and what is the displacement at that place has also changed. Similarly, for shear also you could check that, and similarly for bending moment also it could be checked. Besides that, this is a PSC section, right? So for PSC section, you could check the stress positions at various locations. These locations are shown by the points over here in this small white window, and the maximum and minimum, these points are also shown, the maximum and minimum. Okay, so what is the maximum stress and where it is happening, you could easily check it for any section you want for that particular load case. So this is about the detailed analysis report. Again, we'll be moving to the presentation. Okay, yeah, so this is the upcoming training workshop schedule. We are planning to hold workshops in Mumbai, Delhi, Bangalore, Chennai, Hyderabad, as well as Kolkata within a couple of say 4 or 5 months. And the Mumbai workshop, it's already time for that. It's on 21st February. It's eye girder composite bridge analysis. It will be held in Andheri East, and it's, yes, a free training workshop. So the invitations have already been sent for this. If you have not received the invitation, please do let us know. So by mailing us at techsupport@midasit.com, and we'll mail you the invitation for the Mumbai workshop. Okay. So that's it for today's webinar. And whatever questions you have, please do let us know. And if at all I'm unable to answer all your questions right now, you could send those at techsupport@midasit.com. Okay. So thank you everyone.